This is Pre-Calculus, Chapter 3, Section 4. And in problem number 62, we're to find all of the zeros, and then using those zeros, as well as the y-intercept and our knowledge of end behavior, graph this polynomial. So we're not just finding just the zeros, we're also going to graph it. So in the beginning of this, we have these 5 different steps that we've been doing in finding all of the zeros. We recognize, and then also for this one, we have step 6 because we're going to be graphing. So I know there's going to be 4 zeros. I look at the factors of my constant coefficient, the -8, divided by the factors of my leading coefficient, which is -1. And I list out all of the possibilities of that. And so I have all of these different ones. Now I test them for what's a 0. The only one of those that is a 0 is -2. So I need to do my synthetic division with that -2. And I do my synthetic division, and remember, this is now a polynomial. And I can look at this polynomial and say, well, what would be the zeros of that polynomial? And I would find out that there's another 0 at -2, a second one. So I'm going to do the synthetic division again. And you can see here again that I tested it. I did test it, yeah, but into this polynomial, which would be -1x cubed plus 2x squared plus 6x minus 4. I did test it in there, but the fact that I did the division, I got another 0, shows me that it did go in a second time. Now, what we have left here is a quadratic, so I'm going to use the quadratic formula to find the zeros of that, and we have 2 plus or minus the square root of 2. Since we now have the 4 zeros, that's what we did previously, we found the 4 zeros, we're now going to graph it. We know that the y-intercept is -8, that's our constant coefficient, is our y-intercept. And we know the end behavior, since this is a 4th degree, that the ends will be going on both sides, will be pointing the same direction. Since it's negative, they both point down. So this again is the explanation of the end behavior here. So I also want the decimal equivalent of these zeros. Well, I like these ones, 2 plus the root 2 and 2 minus root 2, for when you're going to tell me what the zeros are, but we're going to graph. It would be good to have a decimal approximation. So I set up my axes. Please note that the y-axis I'm counting by tens, but on the x-axis I'm counting by ones. And the first thing I do is I put all of those important, the zeros, and I also put the y-intercept. And because there are 2 zeros at -2, since it shows up twice, I know that my function is going to bounce off of that 0. And so this is an approximation of what this would look like. And you might say, well, how did you know that this was going to look this way? Well, you could plug in values, plug in these numbers in between here. So I plugged in a 1 and I got a 9, so I went up to 9. I plugged in a 2 and I got 32, and I plugged in a 3 and I got 25. And these extra points will help to give you kind of a basic idea of what it's going to be. It wouldn't be that you're going to graph exactly this function. It's that you would graph something close to it.